Welcome back to Unnati Education videos. So we were studying about physical world. Under that, so far we have studied until what do you call that is unification and reductionism in the last video. So we'll continue from there. Next, we have to see physics is divided into two categories. Mainly, this physics, in order to study, we divide and study, right? So that is better. So physics is divided into classical physics and modern physics. Classical physics and modern physics. So what is classical physics? So it deals with the macroscopic phenomena. See, classical physics deals with macroscopic phenomena and it includes subjects like, see, under classical physics also there are several subjects. So what is classical physics? You understood? No. Deals with macroscopic phenomena. What is that macroscopic? So those things you can see with your naked eyes. That is what you call as macroscopic aspects. So classical physics mainly deals with that kind of subjects. They are under that, the first one, that is mechanics. What is mechanics? Deals with Newton's law of motion, law of gravitation, rocket propulsion, rigid bodies, waves, sound, etc. About all these things we study in mechanics. Okay, next electrodynamics. Okay, electrodynamics also comes under that. So it deals with the electric and magnetic phenomena associated with charged bodies, etc. Okay, then comes optics, deals with study of light. Thermodynamics deals with system concerned with the change in internal energy, temperature, entropy, etc. And also it studies about heat engine. Okay, heat engine. So that is what you call as thermodynamics. So it also comes under classical physics. Then modern physics, the second division that we did in physics, that is modern physics. So it deals with the microscopic phenomena. So what is microscopic? Macroscopic we understood. Classical physics deals with the macroscopic phenomena, but this modern physics deals with microscopic phenomena. What is that microscopic? So you cannot study these things with your naked eyes. Means some instrument is needed in order to study smaller and minute particles. So about that, if you are studying that, that is what you call as modern physics. So that is why it is said that it deals with the macroscopic phenomena and it includes subjects like atomic physics, nuclear physics, radiation physics, soft condensed matter physics, astrophysics, etc. So under modern physics, these things come. Okay. Yes. Next, scope of physics. So why to study physics? What is the reason? What is the use of studying physics, and how from where to where we can study, up to that which we can study in physics? That is actually said in scope of physics. So it is very vast, is vast and contain very large range of magnitude of physical quantities like length. See, 10 to the power minus 14 meter length, 10 to the power minus 14 meter means a very small length. It is almost equal to the size of the electron. From there we can study in physics. From that minute quantity to 10 to the power uh, actually 10 to the power 22 it is, not 2, 10 to the power, it is 10 to the power 22 meter. That is what you call as the size of the universe. size of universe. So when we talk about length, we can study from 10 to the power minus 14 means the smallest length, and to up to 10 to the power 22, that is the largest length. Then mass, mass 10 to the power, here you can see 10 to the power minus 30 kg, mass of an electron, to 10 to the power 55 kg, that is mass of universe. And then time 10 to the power minus 22 seconds to 10 to the power 12 seconds. So these are the extreme ends of different quantities: length, mass, and time. Three basic quantities are there: length, mass, and time. So from the smallest length to the largest length, you can imagine. Similarly, the mass and time. So this much vast scope is there in physics. That is why we have to study physics. Then one more important thing is given here under that. Technology and physics is related to each other. How technology and physics are related? For example, heat and thermodynamics is used in industries. Generation of electricity from solar energy is used in wireless communication, and silicon chip technology is used in computers. Use of alternative energy sources like fossil fuels is also a technological development. Means, in all these examples, what we understand is physics is there. In technology, physics is there. When physics is advancing, with that technology is also advancing, it is also improving, right? That is why technology and physics are related to each other. That is why we have to study physics. Yes, before studying we should understand why we have to study physics, right? That is why I am saying. Next, physics in relation to other science. See, in science, other subjects are also there, right? So, how physics is related to the other science? That is said here. See, the first point: physics in relation to biological sciences. How biological sciences and physics are related. Physics helps in study of biology through its inventions. Optical microscope helps to study biosamples. Electron microscope helps to study biological cells. X-rays have many applications in biological sciences. Radioisotopes are used in cancer treatment, right? So all these things, starting from here: optical microscope, electron microscope, X-ray, radioisotopes, about all these things we study in physics. So they are used in biological sciences. They are very much needed in order to uh, make success of biological sciences. That is why the physics plays an important role there also. Physics in relation with astronomy. See, another example: physics in relation with astronomy. How it is related to astronomy. Giant astronomical telescope developed in physics are used for observing planets. Radio telescopes have enabled astronomers to observe distant limits of universe. Physics related to other sciences. Laws of physics are used to study different phenomena in other sciences like biophysics, oceanography, seismography, or seismology, etc. Okay, so in all other sciences, physics is there. Physics is must. So that is why we have to study physics. Yes. Next, one more thing that we have to understand in before studying physics is conservation laws. Conservation laws are Very common in physics. While studying physics, conservation laws are very common. So what is this conservation law? See, in any physical phenomena governed by different forces, several quantities do not change with time. These special quantities are conserved quantities of nature. Some quantities, for example, energy of a system, energy of an isolated system, energy of a separate system will not change. Hmm? It will be constant. So that kind of some what do you call physical quantities, they will be constant. They will not change. See, another example you might have studied in your high school classes. That is conservation of energy. Energy can neither be created nor be destroyed. It can be transformed from one form to another form. Okay, that is one conservation law. One example for that. This kind of several laws, conservation laws, come in physics. Okay, that is said here. Now you can see some physicists and their major contributions, starting from Isaac Newton, his contribution, law of gravitation, law of motion, reflecting telescope, and his country is UK, United Kingdom. Like that, some more scientists, their name, contribution, and country are given here. You can see the same thing here also. S.N. Bose, C.V. Raman, these scientists are from India, physicists. We have to be proud of them. You can see some more examples here. J.C. Bose is there, right? And M.N. Saha, G.N. Ramachandran, you can see India's physicists. Some more foreign physicists, they contributed much for physics are there. You can observe. Then also laws of physics related to technology, principle of physics and technology, how they are related. You can see here some laws where they are used. You can get the ideas from this table. Okay, you can observe, pause and observe these things. Okay, thank you.